Hi there and welcome to another tutorial for the Edexcel Core 3 Maths A-Level syllabus. This is the next video on differentiation and it is in regards to the product rule. Just taking a look at the scheme of work as always, we have talked about the chain rule and we have used the fact that dy by dx is the reciprocal of dx by dy. What we're going to do in this video is we are going to learn about the product rule and use that to be able to differentiate a whole new set of functions. Okay, to start with, I'm going to just introduce you to the product rule straight away and what it does. If you want a proof of the product rule, I suggest you look online or in your book. It is an interesting proof, it is worthwhile, but I'm not going to do it in this video. You use the product rule to differentiate two functions of x that are multiplied together. And the product rule says the following. If you have a function y, which is a function of x, u of x, multiplied by another function of x, v of x, so y is equal to this function u times another function v, then the derivative dy by dx, the gradient function that is u of x v dashed x plus v of x u dashed x. And there's many ways of writing this, and I'm going to show you the other ways so that in case you saw it in another book. That's the same thing as saying if y is two functions u and v multiplied together and these both functions are of x, then dy by dx is u dv by dx plus v du by dx. And the last one, probably the most shorthand version, probably not the most mathematically correct, but the shorthand version that I usually use when I'm writing out exam answers is if y is equal to u times v, where u and v are functions of x, then y dash, the derivative of y, is uv dashed plus vu dashed. Now that's probably a lot of jargon to take in at the start, very straightforward to understand via an example. So we'll straight away do one example. The product rule. You use it to differentiate two functions of x multiplied together, and I've written my shorthand version in the top right hand corner. We are given that f of x is x squared multiplied by the square root of 3x subtract 1. We are asked to find f dashed x, i.e. the derivative or the gradient function. Now, what two functions are multiplying together here? Well, you've got a function x squared and you've got a function the square root of 3x take away 1 multiplied together. So it's of the right form. In this case, let's say our u is equal to x squared and our v is equal to the square root of 3x minus 1, which I'm going to write in index notation as 3x subtract 1 to the half. Sorry, that was v, not v dashed. So we know in order to work out f dashed x, we're going to have to be able to know v dashed and u dashed. So straight away, let's work those out. U dashed, the derivative of this with respect to x is 2x, and v dash, the derivative of this expression with respect to x, using the chain rule, would be a half, bring down the power of a half, multiplied by this derivative here, this 3x subtract 1 to the negative a half. And v dash would therefore be 3 over 2, 3x subtract 1 to the negative a half. This here was using the chain rule, just in case you're not sure where this came from. This was using the chain rule where you let u equal 3x minus 1. So f dashed x, the derivative of the original function, is uv dashed, so it's x squared multiplied by 3 over 2, 3x subtract 1 to the negative a half, plus vu dash, so v is 3x minus subtract 1 to the half times u dash, which is 2x. Now, I suppose you could say you're done at that point. It's best to tidy it up. It's a bit messy at the moment. I'm going to take this 3/2 out the front. So, and the x squared there. So I'm going to call that 3/2 x squared. 3x subtract 1 to the negative a half. I'm going to take that 2x out the front, so plus 2x, 3x subtract 1 to the half. Again, you're done now. That's probably sufficiently done for f dash x. If you did want to tidy up even further, I'll draw a little line underneath it saying this is not essential, although it could be a show that question in the exam. It could be show that the derivative is what follows. You could tidy this up. You could reconvert this back into its surd notation. So that would mean that f dash x, well, the 3's on top, the x squared's on top, the 2's on the bottom, 3/2, and this is 3x minus 1, 1 over the square root of 3x minus 1. So the square root of 3x subtract 1 would end up on the bottom. And this here, the 2x is on the top, along with the positive, the square root of 3x minus 1. Okay, now you could make them over a common denominator so that they tidied up nicely. So this one therefore would have to be multiplied on top and bottom by 2x, the square root of 3x minus 1. So I might just write that here. If I multiply that, the top and bottom by that, so that we can add this fraction together. Okay, then I would be able to work this out. I would have 3x squared on top. From here, I would have the 3x, the square root of 3x minus 1 multiplied by the square root of 3x minus 1 would just give me 3x minus 1. And the 2 and 2 would give me 4, and I still have the x. So I would have 4x, 3x minus 1 all over 2 square root 3x subtract 1. And I could multiply that out and tidy up just to finish with. That would give me 12x squared. And I've got 3x squared there, so I would have 15x squared subtract 4x all over 2 the square root of 3x take away 1. That would be my f dash x. Now that is fine up here as your f dash x. In particular, if you're asked to work out the gradient at a particular point, you could just sub in using your calculator why create this extra work. Sometimes in the exam they ask you to show f dash x would be this, a tidied up version with the algebra. Okay, time for you to have a go. Pause the video and work through the following. Then check your answers. Okay, we have got that y is equal to x squared 3x minus 1 cubed. So our u in this case would be x squared. Our v in this case would be 3x subtract 1 cubed. Our u dashed, differentiating with respect to x, is 2x. Our v dashed, bring down the power, multiplied by the differential of the brackets, which would be 3, reduce the power by 1, 3x subtract 1 squared. So v dashed would be 9, 3x subtract 1 squared. And dy by dx, therefore using the chain rule dy by dx, well, it's uv dashed plus vu dashed. So it would be equal to x squared multiplied by 9, 3x subtract 1 squared, plus vu dashed, which is going to be equal to 3x subtract 1 cubed, and u dash is 2x. At this stage, it makes your life a hell of a lot easier to just do a bit of factorising. What goes into this term and this term? Well, you know for sure that 1x does, so you can take out a factor of x, and you know that 3x minus 1 squared does. 3x subtract 1 squared does. What would you be left with over here? You'd be left with a 9 and an x. What would you be left with over here? Well, you'd be left with that 2, and you'd be left with multiplied by 3x minus 1. So you'd be left with 2 multiplied by 3x minus 1. You could tidy this up, and you could say that's equal to x. 3x subtract 1 squared. If I tidied this up, the 9x plus the 6x would be 15x subtract 2. I'm asked what the value of dy by dx is at x is 1. So dy by dx at x is equal to 1. Just sub 1 into this expression up here. It'd be 1 multiplied by, this would be 2 squared multiplied by 13. So really you're getting 4 times 13, which gives you the answer 52, and you're done. And that's all on the product rule for this video. I'd encourage you now to go to your exercise book, read page 135, 136 in chapter 8, and do exercise 8b, all of those questions. Thank you very much for watching.